Okay, so in this video we'll talk about another statistical analysis measure, which is standard deviation. So what is standard deviation? Well, it's a measure of the amount of variation or dispersion, also called as spreading of a set of values. So if a data set has values that are spread out, then the standard deviation of that data set is going to be high. And if the spreading is small, the variation in the data set values is small, then the standard deviation is going to be low. The Greek letter sigma is used to denote standard deviation, and the formula to compute standard deviation of a data set X is square root over 1 divided by n minus 1, where capital N is the number of values in the data set X, and we run the summation over the difference of each value in X with its mean. So we define the difference of the value, each value in X with its mean. So how far away is the value from its mean, and we square that, and then we sum up all those values divided by 1 divided by n minus 1, and then find the square root. So that will give us our standard deviation, which will indicate the spreading in the data set. So let's take a very simple example of data set being values 1, 2, 3, and 4, and how we can find the standard deviation of this data set. Well, let's first find the mean of X. The mean of X is going to be the summation of all the values in X, 1 plus 2 plus 3 plus 4, divided by the number of values in X, which are 4. So we would sum up all those values divided by 4, we would get a mean of 2.5. This is the arithmetic mean, or the average. Now, to compute the standard deviation, we would plug in into our formula. The summation is going to run from 1 to 4, because capital N is 4, and each element of xi, x sub I, is going to be subtracted from the mean and then squared. In this case, the data set is 1, 2, 3, and 4, which means x sub I is going to be 1 for the first term, plus second term, third term, and fourth term, because this summation is running 4 times. And then of course we are going to have 1 over 3 as our factor, and then we of course have the square root. So if you simplify all of that, you are going to get 1.29 as the standard deviation. Okay, so this is just a way to calculate the number, which is the standard deviation, but what does it mean in terms of our statistical analysis? Well, if we have a data set which looks like this, when I say it looks like this, I'm talking about the probability density function of the data set looking like a Gaussian function. It is centered around the mean of mu. So the central tendency, or the average of this data set, is mu. It is Gaussian, which means that I have several values, lots of values around mu, and as I go away from mu by 1 standard deviation or 2 standard deviations or 3 standard deviations, the probability of those values happening goes down. So this is a probability density function, and the way we indicate standard deviation on this plot is by the 68, 95, 99.7 rule, which means 68% of the values in the data set are within plus and minus 1 sigma, where sigma is the standard deviation. And then 95% of the values in the data set X, or any data set, is within mu plus and minus 2 standard deviations. And then almost all of the values are within 3 standard deviations. So that's how we calculate the standard deviation and relate it to a probability density function. Note over here, the x-axis is the values in the data set, which are of course centered around the mean mu, and the y-axis over here is a probability measure. So the probability that if you look at any value in the data set, and that the probability that it is going to be around mu is essentially 0.4, and the probability that value is going to be mu minus 2 sigma is very, very small, 0.05. Probability is a number between 0 and 1, So probability 0 means it is not probable at all. Probability of 1 means it's a certainty. It's going to happen 100%. Okay, so now let's try to look at two probability density functions of different standard deviations. So over here we have two PDFs, probability density functions, or sometimes called as probability distribution functions. And one of them is very, very narrow. So the values in this one are very close to the mean. They both have the same mean, it looks like, or at least very close. The one that appears very tall in terms of the PDF has a small standard deviation because it is very narrow. So the chances that a value in the data set is going to be very close to the mean are very, very high. So that means that for a low standard deviation, the data points are going to be very close to the mean suggested by this PDF over here. On the other hand, if we have a very high standard deviation indicated by this PDF, which is very spread out, that's going to indicate that the values tend to be very far away from the mean. So that's how we would compare two PDFs which have the same mean or very close mean but different standard deviations. Now, depending on what data set we are looking at, we could have something that are very tight in terms of the values or very spread out. There's another measure of the spreading in a data set, which is called the variance of a data set. Variance and standard deviation are related to each other. Variance is simply the expectation of the squared deviation instead of the standard deviation of a random variable from its mean. So the variance of x is simply the square of the standard deviation. So if you have the standard deviation, we have used the formula earlier to compute the standard deviation. If you just simply square it, we are going to get the variance of x. Now let's see these two functions, std, which is for standard deviation, and var for variance, and how we can use MATLAB to find the standard deviation and variance of a data set. So I'm going to use the same data set as I've used before, which is the average height of men. And I've already shown you how to find the mean of that data set. Now I'm trying to find the height of that standard deviation of that data set, and I'll also type in variance. So I'm going to copy paste this, and I'm going to say the variance. All right. So by using this function std and var, I can compute the standard deviation and variance of a data set. So if I run this, I'm also in the similar, as I've shown you before, I'm also plotting the histogram, or a very good indication of the probability density function of the data set as well. And let me look at these numbers over here. So the standard deviation height in centimeters, let me look at that first and see how it relates to my plot, the histogram. So as I can see, the standard deviation is about 5 centimeters. The mean earlier noted was 168, so somewhere around here. And if the mean is over here and standard deviation is 5, I would expect 68% of all the values in this data set to fall between plus and minus 5 centimeters off of the mean. So if I look at 168 over here, plus and minus 10 centimeters is going to be about in this range from here to here. And it looks like most of the men have height in that region. So that's about 68% of the data set. So that seems to be a fair estimation based on how the PDF looks like. How about the variance of the data set? Well, I've used the variance formula over here. Let me take a look at that. I expect that to simply be the squared of the standard deviation, which is about 27 centimeters squared. Okay, so I hope you find this video helpful in calculating the standard deviation and variance of a data set, and also being able to use MATLAB to do that for you.